Hey guys, and welcome to our next video. Right, so today we're going to be talking about work and power and how they're calculated. Right, and that picture right there is actually young Arnold Schwarzenegger. So again, he was Mr. Universe, also governor of California at one point. But either way, he was definitely an example of work and power. Right, so definitely a big weightlifter. You can see his muscles are enormous, and that's why he ended up being the Terminator. So, anyway, so let's continue on, talk about work and power and what it means. So, work is basically when force is exerted on an object and that object moves. Okay, so you actually have to have the object move for work to be done. Right, if the object does not move, the work will be zero. Okay, so I'm just kind of pointing that out there. So if you push on a car as an example and it doesn't move, you've done no work. Right? You may be putting effort in, but you're not getting the result of movement. All right, if the object does move, work has been done. Okay, so another example I say, if I'm holding an object such as my phone or book and I'm not moving, I'm not doing any work. Okay, it's not until I actually pick it up or move it up and down that I'm actually doing work. Okay, formula for work. So there's a little bit of math here. So work equals force times distance. It's going to be measured in another unit named after a person, joules. Okay, Jules Verne, I think they were naming it after. Okay, so a capital J, or the combination of Newton and meters called Newton meters. Okay, so those are the two acceptable units. But instead of writing Newton meters, they decided to make joules as a unit, just so they didn't have to write Newton meters all the time. All right, so here's an example. How much work is done to push a car 25 meters with a force of 100 newtons? Okay, so we're going to take work equals force times distance. It's always good practice to write out your formula first and then write out your work. So 100 newtons times 25 meters. And my answer is 2,500 joules. Okay, and if you were just doing the symbol, it would be capital J. Okay, power on the other hand is a measure of how fast work is being performed, right? So it's basically looking at how efficient you are. So what is the power of a tow truck as an example, like Mater here? Okay, so we can use the formula, power equals force times distance divided by time. Okay, or for short, if you already know the work, it would be work divided by time. Okay, so you can combine the two formulas or you can do them separately, all right, depending on what's easier for you. So it depends on what they give you in the problem. So if they give you force, distance, and time, you could use this form of the formula. If they just give you work and time, you use this formula. And the units for this is joules per second, because remember work, the units were joules, and then seconds is the unit for time. Or we can make that what's called watts. Okay, so instead of writing joules per second, once again we just use the term watts. Okay, and you probably have heard that with light bulbs. Okay, so the wattage of the light bulb is a calculation of power. How much power is being consumed by that light bulb each second. So here's an example. A tow truck exerts a force of 11,000 newtons to pull a car 5 meters in 10 seconds. So all I have to do, take this form of the formula because I have force, distance, and time. Multiply your force times your distance. I usually put that in parentheses. Divided by 10 seconds. Okay, so 11,000 times 5 divided by 10. And my final answer will be 5,500 watts or 5,500 joules per second. Okay, so also who did more work and which had more power? So an example here, raking leaves versus blowing leaves. Okay, there's a reason why we tend to go for the blower. All right, so who did more work raking the same amount of leaves? Well, they did the same amount of work, right? So they might have the same amount of leaves exactly. The only difference, so same amount of leaves, same amount of distance, the same size property. Okay, but who had the more power? The leaf blower, because it can potentially do the work faster. All right, so it can move those leaves at a faster speed, and therefore the work actually will, it's the same amount of work done in less time, so therefore it has more power behind it. Okay, because work divided by time is power. Okay, so Big Bad Wolf story, you guys know, tried to blow down the 3 pigs' houses. When did he do no work? Well, that last pig, right? So that last pig had the brick house. There was no movement when he huffed and puffed and blowed the house down. So therefore, no work was done. Okay, so how could the wolf increase his power of knocking down the houses? Well, blowing faster if he could. Hurricane force winds probably can't even take down a brick house, though. Sometimes actually it can. Depends on how strong it is. All right. Or obviously using an object with more force behind it, because wind compared to a wrecking ball, obviously a wrecking ball is going to do more damage. All right, and that's it for work and power. So you guys will do some calculation examples and practices. Thank you guys for tuning in.